myself I am from HM College Karad. In previous video, we learned about derivative as a rate measure. Derivative as a rate measure means dy by dx, derivative of y with respect to x is a rate of change of y with respect to x. Rate of change of y with respect to x is nothing but dy by dx. The examples on derivative as a rate measure can be identified by the word rate. To solve the examples, the working steps are first identify the geometrical figure, write given and to find quantities. First write given and to find quantities. Second is use the formula for the geometrical figure. Use the formula. Third step is differentiate that formula with respect to t. Why we differentiate with respect to t? Because all the things in universe are dependent on time. So t is a time. So differentiate with respect to t. And fourth step is solve or simplify for required answer. Simplified for required answer. These are the working steps to solve examples on derivative as a rate measures. Remember here, write given and to find quantities. Use the formula for the geometrical figure. Differentiate with respect to t. On differentiating, solve for required answer. These are the working steps for the examples on derivative as a rate measures. Derivative as a rate measures याचे एक्झाम्पल्स तुम्हाला ओळखायचे असतील तर रेट हा शब्द त्या प्रॉब्लेम मध्ये येणार आहे आणि हा प्रॉब्लेम वर्ड प्रॉब्लेम असणार आहे. खूप सिंपल प्रॉब्लेम्स आहेत. आपण ते प्रॉब्लेम्स पाहूया. फर्स्ट प्रॉब्लेम. The first example is the age of a cube is decreasing at the rate. Here is that word rate. Of 0.6 centimeter per second. Find the rate at which its volume is decreasing when the age of the cube is 2 centimeter. Look at here. The geometrical figure is cube. I can draw here a cube. This cube is like this. First, the age of the cube is decreasing. Suppose that age of the cube, that is side of the cube is x and it has volume is v. I can solve this as let x and v be x is side and volume of cube at any time t. Now moving to our first step, write the given and to find quantities. Look at here, rate of change of, look at here, the rate of change of age is 0.6. We are considering that age is x. If x is the side of the cube, then dx by dt is nothing but a rate of change of age. So it is given that dx by dt, rate of change of age, is 0.6 centimeter per second. But the rate of change of age is decreasing. That's why I can take here negative sign. When function is decreasing, derivative is negative. When function is increasing, derivative is positive. So I can take here negative sign for notation to denote the function is decreasing. Now, to find, what is to find? Find the rate at which its volume is decreasing. Rate of change of volume. If V is the volume, then rate of change of volume is nothing but dV by dt. Rate of change of volume is dV by dt. To find dV by dt, find the rate at which volume is decreasing when the age of the cube is 2 cm. When age of the cube, that is x is equal to 2 cm. Question. Okay, first step is completed here. Write the given and find quantities. Second step is use formula. Use formula for that geometrical figure. Here geometrical figure is cube, and we know that the formula for volume of a cube, we have volume of cube V is equal to side cube. V is equal to side cube. Side is what? X. So x cube. Now we differentiate. Second step is completed. Now we differentiate with respect to t. Differentiating with respect to t. Look at here, the variables are volume and side. Side is decreasing, volume is decreasing. So these are variable quantities, and we differentiate with respect to time. Therefore, derivative of v with respect to t is dv by dt. Derivative of v with respect to t is dv by dt is equal to derivative of x cube is 3x square. Look at here, derivative of x cube is 3x square. When it is 3x square, if we differentiate that with respect to x, but here we differentiate with respect to t. So derivative of x cube is 3x square into dx by dt multiplied by dx by dt. Okay, so 3x square as it is into value of dx by dt is given. It's 0.6. Value of dx by dt is 0.6 from given, and it is decreasing. So I can take minus 0.6. dx by dt is minus 0.6, which is equal to minus 0.6 into 3, 1.8, 0.6 into 3, 1.8 into x square. It's dv by dt, rate of change of volume. dv by dt is equal to minus 1.8 into x square. To find, what is to find dv by dt at x is equal to 2 and x is equal to 2. Therefore, dv by dt at x is equal to 2, which is equal to minus 1.8 into what is the value of x? It's 2 square, which is equal to minus 1.8 into 2 square is 4. 4 8s are 32. 4 1s are 4. It's minus 7.2. dv by dt at x is equal to 2. Negative sign indicates that. Negative sign indicates that volume is decreasing. Look at here. Find the rate at which the volume is decreasing when the age of the cube is 2 cm. So I can write here, therefore volume of cube is decreasing at the rate, yes, minus 7.2. Since the word is decreasing here, write positive quantity 7.2, and unit for cube volume, unit for volume is cubic units. So unit is centimeter cube per second. It's our first example. Centimeter cube per second, 7.2 centimeter cube per second. That is the rate at which volume is decreasing when the age of the cube centimeter is 7.2 centimeter cube per second. Now we are moving to our next example. Second example is if each side of an equilateral triangle, increases at the rate of root 2 centimeter per second. Find the rate of increase of its area. Find the rate of increase of its area when its side of length 3 centimeter, when its side of length 3 centimeter. In this example, the word rate is there. So clearly the example is on rate measures. The words rate are there. So clearly the example on rate measures. First working step is find the geometrical figure and write given and to find quantities. Here geometrical figure is equilateral triangle. So I can draw here equilateral triangle. Means sides are equal. These sides are equal. That triangle is ABC. If X is the side of the equilateral triangle, I can solve this example. Let X be the, and equilateral triangle has area. So X and capital A be the side and area of equilateral triangle at any point T, or at any time T. Now if side is increasing, then its area is also increasing. So area and sides are variables given. What is given in the example? Side of an equilateral triangle increases at the rate. If X is the side of equilateral triangle, then rate of change of side is nothing but dx by dt. So dx by dt is given. Dx by dt is equal to root 2 centimeter per second. Dx by dt is root 2 centimeter per second. To find, what is to find? To find here, find the rate of increase of its area. If A is the area of equilateral triangle, then rate of change of area is dA by dt. So to find dA by dt when the its side of length 3 centimeter, that is find dA by dt at x is equal to 3 using formula. What is the second step? Use formula. We have, what is the formula for equilateral triangle? In between two variables x and a, means side and area. We have area of equilateral triangle is equal to, the formula for area of equilateral triangle is root 3 divided by 4 into side square. Root 3 by 4 into side square is the volume of is the area of equilateral triangle. So next step is differentiate with respect to t. On differentiating with respect to t, therefore derivative of a with respect to t is dA by dt. Root 3 by 4 is constant, so as it is, into derivative of x square is 2x into we are differentiating with respect to t, so multiplied by dx by dt. Don't forget to multiply dx by dt. 2 2s are 4, so it's root 3 by 2 into x into value of dx by dt is root 2. Value of dx by dt is root 2. Now root 3 into root 2, root m into root n, root mn, root 3 into root 2, root 6 divided by 2 into x. It's dA by dt, but we have to find here dA by dt at x is equal to 3. At x is equal to 3, dA by dt and x is equal to 3. It's in centimeter, 3 centimeter, which is equal to root 6 divided by 2 into 3. I can write this as 3 root 6 divided by 2. So which is required rate of change of area with respect to time at x is equal to 3. Thus I can say here the rate of increase of its area is 3 root 6 divided by 2 when the side is 3 centimeter, and unit for this area is square unit. So centimeter square per second, centimeter square per second is the unit of that rate of change of area. Now we are moving to next example, question number 3rd. Question number 3rd. A stone is dropped into a quiet lake and waves in the form of circles are generated. Radius of the circular wave increases at the rate, here is the word rate, 5 centimeter per second. At the instant when the radius of the circular wave is 8 centimeter, how fast the area enclosed is increasing. So remember here the word rate is there, so example is clearly on rate measures. First step, geometrical figure. What is the geometrical figure? Write given and to find properties. A stone is dropped into a quiet lake. Quiet lake शांत तलाव आहे, त्या तलावामध्ये दगड टाकलेले आहे. So quiet lake is clearly a circle. Clearly a circle. That geometrical figure is identified here. That geometrical figure is circle. And waves in the form of circles are generated. आणि काय झालेलं आहे, दगड टाकल्यानंतर वेव्स झालेले आहेत. वेव्स झाल्यानंतर मग काय होणार आहे, रॅडियस वाढणार आहे. रॅडियस वाढली की काय होणार आहे, त्या सर्कलचा एरिया वाढणार आहे. म्हणजे रॅडियस आणि एरिया हे व्हेरिएबल क्वांटिटीज आहेत. सो आय कॅन राईट स्टार्टिंग स्टेप लेट. First step is write given and to find quantities. First I can write let for circle I can take r is the radius and a is the area. So let small r and capital A be the radius and is the area of circular waves. Given. What is given here? Given is what? Radius of the circular wave increasing at the rate. the radius, then dr by dt. If r is the radius, then dr by dt is rate of change of radius. Means radius is increasing at the rate. Means dr by dt is given. So dr by dt, which is equal to, it given 5 centimeter per second. Now, at the instant when the radius of the circular wave is 8 centimeter and r is equal to 8, how fast the area enclosed is increasing? How fast the area enclosed is increasing? That is to find, if A is the area, then rate of change of area is denoted by dA by dt, since derivative has a rate measures. So here to find dA by dt when radius is 8 centimeter, when r is equal to 8 centimeter. Now first step is completed. To find dA by dt, we use the formula in between radius and area of the circle. What is the formula for radius and area of the circle? We have area of circle is nothing but pi r square. Area of circle is pi r square. Second step is completed. Now third step is differentiate with respect to t. So I differentiate that formula with respect to t. Why with respect to t? As time increases, radius increases. When radius increases, volume area increases. So differentiating with respect to t. Therefore, dA by dt is equal to, pi is constant, but r is not constant. Since time is increases, radius is increases. So r is a variable. Derivative of r square is 2r into, we are differentiating with respect to t. So multiplied by dr by dt. Multiplied by dr by dt, which is equal to 2 pi r into, here dr by dt is given 5. Dr by dt is 5, which is equal to 10 pi r. It's dA by dt, but we have to find here dA by dt and r is equal to 8. So, and r is equal to 8 centimeter. R is equal to 8 centimeter. dA by dt and r is equal to 8 centimeter, which is equal to 10 pi into, value of r is 8. 10 into 8, it's 80 pi. 80 pi. It's a rate of change of area, and unit of area is square units. So centimeter square per second. The rate of change of area, or area, is increasing at the rate 80 pi when radius of the circular wave is 8 centimeter. Here is the final answer of the given question. That is, at the instant when the radius of the circular wave is 8 centimeter, the area is increasing at the rate 80 pi centimeter square per second. Now, next example is, water is being poured at the rate of 36 meter cube per second into a cylindrical vessel of base radius 3 meters. Find the rate at which water level is rising. Look at here, the word rate is in our example. So the example is on derivative as a rate measures. First step is find the geometrical figure. Water is being poured at the rate of 36 meter cube per second into a cylindrical vessel. Cylindrical vessel means clearly the geometrical figure is a cylinder, and cylinder has quantities, yes, base radius, height and volume. So starting with Lect, small r in meter, small h and volume V be the radius, height and volume of cylindrical vessel at any time t. क्वेश्चन मध्ये काय सांगितलेलं आहे की वॉटर इज बीइंग पोर्ड, पाणी भरायचं चाललेलं आहे त्या सिलेंड्रिकल वेसल मध्ये. म्हणजे जसं टाइम वाढेल तसं काय होणार आहे, वॉटर लेवल वाढणार आहे. वॉटर लेवल वाढणार आहे म्हणजे त्याची हाईट पण वाढणार आहे आणि त्याचा व्हॉल्यूम पण वाढणार आहे. म्हणजे हाईट आणि व्हॉल्यूम हे तुमचे कसले गोष्टी झाल्या, व्हेरिएबल क्वांटिटीज झाल्या. सो फर्स्ट स्टेप इज राइट गिवन अँड टू फाइंड क्वांटिटीज. गिवन, व्हॉट इज गिवन हियर, water is being poured at the rate of 36 meter cube. Meter cube, cubic unit is unit of volume. So it is given that if V is the volume of the cylinder, then rate of change of volume is dV by dt, and the rate of change of volume is given dV by dt is equal to 36 meter cube per second. लक्षात घ्या, इथे युनिट मध्ये मीटर क्यूब आलेला आहे म्हणजे व्हॉल्यूम दिलेलं आहे आणि व्हॉल्यूमचा रेट ऑफ चेंज आहे म्हणजे dV by dt दिलेलं आहे. अजून एक गोष्ट दिलेली आहे, अँड बेस रॅडियस ऑफ बेस रॅडियस दिलेली आहे आपल्याला. बेस रॅडियस काय सांगितलेली आहे, 3 मीटर्स. r इज इक्वल टू 3 मीटर्स. म्हणजे की आपल्याला रॅडियस दिलेली आहे 3 मीटर आणि आपल्याला टू फाइंड मध्ये काय करायचं सांगितलेलं आहे बघा. Find the rate at which water level is rising. Water level म्हणजे काय, हाईट त्या पाण्याची काय होते, वाढते, ते काढायचं. रेट ऑफ चेंज ऑफ हाईट, दॅट इज dH by dt is equal to क्वेश्चन. तो आपल्याला काढायचा. आता आपण पहिल्यांदा काय केलेलं आहे, गिवन क्वांटिटीज दिले, टू फाइंड क्वांटिटीज दिलेले. आता फर्स्ट स्टेप कंप्लीट झालेली आहे. सेकंड स्टेपला काय करणार आहे, आपण फॉर्म्युला यूज करणार आहे. वी हॅव, आता आपल्याला कोणता फॉर्म्युला माहित असला पाहिजे, व्ही आर आणि एच मधला. सो व्हॉल्यूम ऑफ सिलेंडर हा फॉर्म्युला आपल्याला माहिती असणे गरजेचे आहे. व्हॉल्यूम ऑफ सिलेंडर इज डिनोटेड बाय व्ही इज इक्वल टू पाय आर स्क्वेअर एच. जर तुम्हाला हा फॉर्म्युला माहिती नसेल तर एक्झाम्पल सॉल्व्ह होणार नाही. सो रिमेंबर दिस फॉर्म्युला. Volume of the cylinder is equal to pi r square h, but it is given that r is equal to 3. So V is equal to pi into 3 square h, which is equal to 3 square is 9 pi h. The formula is V is equal to 9 pi h. Differentiate with respect to t. Now third step, differentiate with respect to t. So dV by dt is equal to 9 is constant, pi is constant. Derivative of h is with respect to h is 1. Since it is differentiated with respect to h, multiplied it by dh by dt. So derivative of h is dh by dt. But we have to find dh by dt. So I can solve this for dh by dt. dh by dt is equal to dH by dt is equal to, it becomes dV by dt is given, I can write here dV by dt, value of dV by dt. dV by dt is given, it's 36 is equal to 9 pi into dH by dt. Therefore, dH by dt is equal to 36 divided by 9 pi. 9 fours are 36. 4 divided by pi is dH by dt. Means dH by dt means what? The rate at which water level is rising. The rate at which water level is rising is 4 divided by pi, and unit for height is meter per second. Unit of height is meter per second. So final answer is the rate is 4 divided by 2 pi. Water level is rising. Here is the final problem. I hope you understand today's problems on derivative as the rate measures. Thank you for watching the video.